Example 3, the absolute value of 4 minus 3x less than or equal to 13. We have to use this property in this example. If absolute value of x is less than a, then x is greater than negative a but less than a. So we can use that in this inequality. We see that the absolute value expression is isolated on the left side, so we can apply the property immediately. Therefore, we have negative 13 less than or equal to 4 minus 3x less than or equal to 13. Or we can say that 4 minus 3x is in between negative 13 and 13. Let's isolate x by getting rid of 4 first. So we subtract 4 to, all members by 4. Negative 13 minus 4, that gives us negative 17 less than or equal to negative 3x. We get to cancel 4 minus 4, and that is less than or equal to 9. Dividing all members by negative 3, we'll have positive 17 over 3. Of course, we cancel negative 3 is x, 9 divided by negative 3, negative 3. Note that we've used negative 3 as a divisor, so the direction of our inequality changes. So from less than or equal to is now greater than or equal to. Same thing here, greater than or equal to. But 17 over 3 can be changed to mixed number, and that's equivalent to 5. So 17 divided by 3. Of course, the quotient is 5, remainder 2 over 3. Okay, so that's 5 and 2/3. And this is still negative 3. We can write this in the standard form. In the standard form, which is a less than b less than c. Of course, we have to write negative 3 here first, a smaller number. And we have 5 and 2/3, a bigger number, x here. And in standard form, when we consider x greater than or equal to negative 3, the inequality opens towards x. So we can write here now less than or equal to x, which opens towards x. And then if we consider 5 and 2/3 greater than or equal to x, the inequality opens towards your 5 and 2/3. So that will now be less than or equal to, which opens towards 5 and 2/3. And that's our solution set in inequality form. So that means that our solution is in between negative 3 and 5 and 2/3, inclusive of the negative 3 and 5 and 2/3. Let's also graph the solution set. We have negative 3 and then 5 and 2/3. We see that negative 3 is included. We have less than or equal to, 5 and 2/3 less than or equal to. So that means that negative 3 and 5 and 2/3 are included. So for negative 3, it's close. And for 5 and 2/3, it's close. And the solutions, the other solutions are in between negative 3 and 5 and 2/3. We can also write this into interval notation. We have to use bracket because negative 3 is included. And 5 and 2/3, we use close bracket because 5 and 2/3 is also included. So the interval notation is the closed interval, negative 3 to 5 and 2/3.